Hi, class. Now that you have an understanding of the differences between parametric and non-parametric measures and when you would use each one, let's go ahead and take a look at the first kind of research study. Chapter 5 discusses research that compares two independent groups. I'm going to back up just a little bit to one of the most basic statistical tests you could use, which is the z-test. This is going to be used when you have one sample and one variable and you know what the standard deviation is. The only thing you don't know is the true population mean. So that's the only thing that you could possibly be wrong about when you're thinking about your data. However, if you don't have enough information about your data to use the z-test, we're going to look to t-tests. We think that the data is normally distributed, but we don't know the mean or the standard deviation. And it's possible that we could be wrong in our thinking about these two things, but we have enough information to decide that the parametric test is the correct choice. When we might also be wrong about whether or not the data is normally distributed, or a third thing, we would go ahead and use the non-parametric test. Now, Chapter 5 looks at the parametric independent t-test and the non-parametric Mann-Whitney u-test. These are used when you have a dichotomous independent variable, which means that you only have two options. So like you would have male or female, someone who's either a smoker or a non-smoker, okay? You believe that the two groups are different, so what you're going to do is test to see if they are the same so that you can reject that idea, which is, again, your null hypothesis, okay? Because you want to support your alternate hypothesis. So that null hypothesis says that there's no difference at all between the groups. And so again, you believe there is a difference, so you want to find information that will justify it when you reject the null. Now, independent t-tests are used when you want to compare the mean scores on some continuous variable for two different groups of people or conditions, and there's no direct link between the individual observations in each group, so no pairing, which we'll deal with that in the next chapter. An example would be, let's say you want to know if there's a significant difference in the mean self-esteem scores between males and females. So in that example, you have one categorical independent variable, so either male or female, and one continuous dependent variable, which is their self-esteem score. The independent t-test will tell you if there's a statistically significant difference in the mean scores for the two groups. As much as we would like to just calculate the means of the two groups and use those relatively simple numbers to decide if the groups are or are not different, we need the statistical calculations to tell us if any observed difference is statistically significant or not. Simply noticing that the means are different is not going to be sufficient evidence to support or reject your hypothesis. The Mann-Whitney u-test is the non-parametric alternative, and instead of comparing the means of the two groups, this test actually compares the medians. It converts the scores of the continuous variable into ranks across the two groups, and then it evaluates the ranks for the two groups to see if they differ significantly. When the scores are converted to ranks, the actual distribution of the scores doesn't matter. So let's go ahead and walk through the steps of each calculation, and we'll see how the output in SPSS looks different when it comes time to interpret the results. So let's see if I can go ahead and get this to share the screen. There we go, the entire screen. And there we go. And we'll hurry up and open up SPSS. There we go, so you don't have to look at that screen too much. All right, now, to calculate an independent t-test in SPSS, you're going to open up the program and your data set, which that's what this is. Now, from the menu at the top of the screen, you're going to pick Analyze, and then Compare Means. Oops, I always go a little bit past. And then Independent Samples t-test. Okay? Now what you're going to do is move the dependent or continuous variable. In this case, we've got total self-esteem, so we look for that variable on the list. And here it is, total self-esteem, okay, into the test variable box. And then the independent variable, the categorical variable, which is sex, we're going to move that into the box labeled grouping variable. Okay, then we're going to click on Define Groups, and type in the numbers that were used in the data set to code each group. So in this particular data file, males are 1 and females are 2. Okay, so you put 1 in the group 1 box, 2 in the group 2 box. And if you can't remember the codes that were used, you can always right-click on the variable name and then choose variable information from the pop-up box that appears. This is going to list all the codes and labels. Okay, so from here you click on continue, and you're going to click on OK. So now your results in SPSS look like this. And now it's time for us to interpret the output. In the group statistics box, which you can see right here, you can see the mean and the standard deviation for each group. Now, it's also a good idea to make sure the number of people in each group matches what you think it should be. Okay, these numbers right here. If it doesn't, that means you need to find out why they're different. Okay, we also want to consider a test that will give us a little insight into whether or not our samples had equal variance. So let me go ahead and scroll down a little bit. This is going to tell us which line in the output box we're going to use. Now, we want to start by thinking again about whether or not we believe the groups have any natural differences that might affect their variance. Perhaps we are looking at two third grade classrooms within a single elementary school. We would have no reason to think that the kids weren't randomly assigned to the rooms, so we would assume equal variance between these two groups. If Levine's test, and we'll talk a little bit more about that in a little bit, but if Levine's test rejects this logical assumption that the variance is equal, we would want to investigate and find out why we got that result. So in our example, maybe the kids weren't really randomly assigned after all, right? Maybe the school principal separated them intentionally for some reason. So Levine's test is something that would warn us that we might be wrong in our assumptions. In this particular case that we're working at with self-esteem, we would have no reason to believe that men and women perceive things the same way, and that means including views on self-esteem. Okay, so let's look to the first section of the independent sample test output box and look for Levine's test for equality of variance. Okay, if that value is larger than 0.05, you should use the first line in the table, which is equal variance is assumed. Okay, if the Levine's value is p equals 0.05 or less, that means that the variance for the two groups is, the variances for the two groups are not the same, and your data is violating an assumption. This is okay because SPSS is going to compensate for that, and you can use the values in the second line, which is called equal variances not assumed, as you can see right here. But in this example, the level is 0.06, you can see right here, which is larger than the cutoff of 0.05. So you can assume equal variance has not been violated, and you're going to use the first line in this table. Now you get to see if there's a significant difference between the two groups. So you look to the column labeled sig two-tailed, okay, right here. And if the value here is equal to or less than 0.05, there is a significant difference between the groups. If the value is above 0.05, there's no significant difference. You already know to look at the value on the first line, right, which is 0.105. Since this value is above the cutoff of 0.05, you can conclude that there is not a statistically significant difference in the mean self-esteem scores for males and females. So you can't reject your null hypothesis. Now, if you were going to read these results in a journal article, it would look like this. Find that for you. There we go. Okay. An independent samples t-test was conducted to compare the self-esteem scores for males and females. There was no significant difference in scores for males where you've got your mean and your standard deviation listed, and females, again, mean and standard deviation listed. Okay? Now we're going to go ahead and look at the non-parametric alternative using the same research question. Now, in this particular case, you want to keep in mind that lots of psychological tests have been normed in such a way that they would force normal distribution, and this would allow us to use the more powerful t-test. However, if you weren't sure if this was the case, or if you had some reason to logically believe that the distribution was not normal, you would go ahead and use the non-parametric test. Now, you can always create a stem and leaf plot to make this decision, which our book for this class shows us how to do. But for the sake of seeing how to do the calculations in SPSS, let's just work with the assumption that we've already done that and the distribution is not normal. So we're going to use the Mann-Whitney-U test. All right, so let's get back to our data set. Okay, same data set. And the Mann-Whitney-U test is going to be started in the same way. Open a SPSS, the appropriate data set, and at the top of the screen, you're going to pick Analyze, and then non-parametric tests, and then independent samples. Okay? In the Objective tab, you're going to click Customize Analysis right here, and then click on the Fields tab, and move your categorical, your independent variable, which is sex, into the group box. Okay, your dependent continuous variable, remember, which was total self-esteem. So here's total self-esteem. Move that into the test fields box. Okay, then you're going to click on the Settings tab and select Customize Tests, Mann-Whitney U2 samples, and then you're going to click the Run button. Now, there we go. Non-parametric test. Here's what the SPSS output is going to look like, and we'll just take a quick look at how to interpret the information. Okay, the hypothesis test summary, this box right here, gives us the quick summary of the results. The significance value is 0.220, which is not less than 0.05. Remember, you see that down here as well. So the result is not significant. Now, if you found there was a statistically significant difference, you would need to describe the direction of the difference or which group has scored higher. When you're doing your reporting, you would likely want to report the median values for each group, which requires you to perform one more step, right? You would go back to the menu and choose Analyze, Compare Means and Means. Let's go ahead and just do that. Let me move this down. So you're going to say Analyze, Compare Means, and Means. Then you're going to move the continuous variable, the self-esteem. Let's go ahead and move that in there. Total self-esteem into the dependent list box, and categorical variable of sex into the independent list box. Okay. Then you click on Options. Then you're going to make sure you need median moved over to the cell statistics. You want mean out of there, standard deviation out of there, and we'll go ahead and take number of cases. We'll leave number of cases in there. That should be fine. Okay, then you're going to click Continue and OK. Then the output is going to look like this. Now, SPSS doesn't give you an effect size statistic for this test, but you can calculate it yourself using the z-value, which you can find in the test summary table. Okay, let's get back to that. In this case, z is going to equal negative 0.123, and n is 436. You can see the n is right there. Okay. So the R value is 0.06. What you're going to do is take the z-score and divide it by the square root of n being the total number of cases. Okay, so again, you're going to get an answer of 0.06, which would be considered very small using the criteria where 0.1 is small, 0.3 is medium, and 0.5 is a large effect. Now, if you saw this reported in a journal somewhere, it's going to look like this. A Mann-Whitney-U test revealed no significant difference in the self-esteem levels of males and females. And remember, it's showing the median score and the number of cases. In our next Collaborate session, we'll work through each of these calculations together using a different data set. And next week, we're going to look at different calculations used when we compare two paired groups in our study. All right, so I'm going to go ahead and stop sharing all of this. Let me just get back to where I need to be, and have a great